المعرفة International Private School Thermal Physics IGCSE 0625 Learning Objectives 233 Radiation Core Identify infrared radiation as part of the electromagnetic spectrum. Recognize that thermal energy transfer by radiation does not require a medium. Describe the effect of surface color, black or white, and texture, dull or shiny, on the emission, absorption, and reflection of radiation. 234 Consequences of energy transfer. Core, identify and explain some of the everyday applications and consequences of radiation. Supplement, describe experiments to show the properties of good and bad emitters and good and bad absorbers of infrared radiation. Second supplement, show understanding that the amount of radiation emitted also depends on the surface temperature and surface area of an object. Thermal exchange or heat transfer through three methods: conduction, convection, and radiation. I'm going to share with you one of nice simulation about conduction. Now look at this simulation about conduction. We have a heat resource, and we have here a hot plate and also a cooking pan, as well it is attached to a wooden handle. When we switch on the hot plate, see how the adjacent molecules start to gain more of kinetic energy and they vibrate more. Then they transfer the increase in kinetic energy to the other molecules from hot plate to the cooking pan. Then after, it transferred also to the metal that is attached to the wooden handle. So as you see, metal is a good conductor. Metals, they have freely electrons to transfer thermal energy. But in the wooden part here, the vibration and the increase in kinetic energy does not transfer, as the insulator or poor conductors, they don't have freely electrons to transfer the thermal energy or the increase in kinetic energy. Also, this simulation about convection, I'll show you the convection through the heater. So the convection current of air, the cold one that is going down with high density, the hot one that is going up with low density, and the circulation between the hot current and the cold current helps to distribute the thermal energy throughout the gas of the room. In liquids also, see this container of liquid, how the hot current goes up as its density decreases, and the cold current replaces it as its density is more. And this will help to circulate the convection currents throughout the liquid. Return back to our slides. Yes, here it is. So we said that thermal energy transferred through heat, conduction, convection, and radiation. Now we're going to explain the third way, which is radiation. Now, radiation is the part of electromagnetic spectrum, as you see this section, that is consists of the thermal radiation. So energy travels to us from the sun in the form of electromagnetic radiation. The waves, they can travel throughout the vacuum of space and as well throughout the atmospheric layers around the Earth. Now, the thermal radiation includes the invisible infrared waves as well as visible lights. Now, all objects give out some of thermal heat radiation. Warm objects give out infrared radiation. As objects become hotter, So they start to give out shorter wavelength and such as light. This is why hot objects such as grills glow as they continue to heat up. Now, the surfaces are divided into emitter surface or absorber surface. Emitters means give out thermal energy or thermal radiation. Absorbers means take in thermal radiation. Now, usually good emitters, surfaces of heat energy, are also good absorbers of heat energy. Look at this chart. Now we have three surfaces: matte black, white, and silver. Usually, matte black is best in emitting and absorbing radiation, while silver and white, they are bad and worst in emitting and absorbing radiation. Silver and white, they are best reflectors of radiation. One of the applications they use to paint the houses with white color in the hot countries. This will help to reflect most of the radiation to keep the inside home with low temperature. Now, also this chart with more details. Dull black surfaces are good emitters and absorbers of heat. Shiny white surfaces are good reflectors. So as well, they are bad emitters and absorbers of heat. Now, the factors that affecting the rate of infrared radiation. We have three factors. First factor, color and texture of the surface. Dull black surfaces are better absorbers and emitters of infrared radiation than shiny white surfaces. Second factor, surface temperature. The higher the temperature of the surface of the object relative to the surrounding temperature, the higher the rate of infrared radiation. Third factor, surface area. If two objects, they have same mass and same material, now the object that has more of surface area, for sure this object will have higher rate of radiation. Look at this figure. We have two blocks here. One is painted with black matte and second one with silver shiny color. As you see, they expose and in same time interval to the sunlight. See the raise in temperature for the black one and the raise in temperature for the silvery one. So the temperature raise quickly in the black one as it is best absorber, and for this one, the silver one, it is bad absorber, so the temperature raises slowly. Now, second application, the color of this t-shirt. Dull black surfaces are better absorber than shiny white surfaces, and here shiny white surfaces are better reflector than dull black surfaces. Now look at this required experiment in IGCSE. We have a cube here that is consists of three faces or surfaces. And also there is opening from the upper side. This face is a black face, white face, and silver face. From this side, we have to fill the metal cube with hot water. Then the other apparatus is the thermal radiator detector, and that is attached to a meter. Now, after filling the cube with hot water, all surfaces, they will reach same temperature. Then we have to place the detector from equally distances from each face and to the same time interval. Then after, I will have three values, three data here. First one from the black face, second one from white, and third one from silver one. Through this experiment, we can observe which face is the best emitter and bad emitter of radiation. So the thermal radiation detector compares the amount of heat energy emitted from different phases. Through the values that we will record from the meter, we can detect and compare between the three phases with three colors. The second experiment is this one that we have here, heater resource or radiator, and we have two metal plates, one that is colored with matte black, second one shiny silver plate. And as you see, they placed from two sides with equal distances from the heater, and each one attached with one thermometer. Then after, we have to switch on the radiator for some time interval. So after each surface will absorb some of heat radiation from the heater for the same time interval. So as you see, the thermometers are attached to the metal plates, which are placed in equal distances from the heater. Then after, from the thermometers, we can detect which surface is higher in absorbing the radiation. For sure, for this experiment, the temperature that is recorded from the thermometer that is attached to the matte black surface will be higher than the temperature that is attached to the silver shiny surface, since we learned that the matte black surface is best absorber to the radiation. So the conclusion through these two experiments, the first one that compared the emitting of radiation from the three surfaces by using this cube and detector with ammeter. The metal cube is filled with boiling water, which heats the surfaces to the same temperature. The thermal radiation detector is placed in turn at the same distance from each surface, and the meter reading are compared to detect which one is the first one in emitting radiation, second and third. The second experiment here to compare the absorbing of radiation. The metal plates are placed at same distance from the heater to find out which surface absorbs thermal radiation most quickly and rapidly. The raises and temperature are compared to compare which one is the best absorber, which one is the bad absorber of the radiation. Now, before this question, I'll share with you a nice video about the factors affect thermal radiation. So as you see, here is the video. Here we have two blades. One is silver, one is black. As you see here, they attach one piece of wax from same distances from the ground. And as you see, after some time interval, we want to see which one will fall down. So as you see here, we will wait some time until see, as you see, the black one, then the silver one. So the wax firstly, yes, falls down from the black one, then the silver one. So the reason of this, that dull black surfaces, they are better absorbers of radiation. Shiny silver surfaces, they are bad absorbers to the radiation. Look at this second one. We have two containers from same size. This one is painted with matte black, and this one silver, shiny silver. We filled inside same amount of boiling water. Then we insert here two thermometers. So as you see, the temperature is equal 90 Celsius, 90 Celsius. And now we have to wait some time to see. Yes, so as you see, the matte black temperature falls down quickly, while the silver takes more time to fall. So the reason of this, yes, that dull black surfaces, they are better emitters of radiation than the silver shiny surfaces. So yes, this is the conclusion of these two experiments. Both, yes. Now the second one, this is the conclusion of the two experiments, the previous two experiments. Now the curve, cooling curve. I'll show you the cooling curve. See this cooling curve, temperature and time. See what happens to the gradient along this curve. As you see, the gradient decreases. What is the meaning that the gradient decreases? See this triangle that will let you and help you to measure the gradient. So as you see, the gradient decreases because the emitting of radiation will be higher at a higher temperature, and the emitting of radiation will be less at a lower temperature. See here in this figure, we have two blades. This is the third factor affect the rate of radiation. We have here a small surface area, and here we have a big surface area, and the rate of radiation will be more for more surface area. Yes, smaller surface area here and bigger surface area here. So bigger surface area, the rate of radiation and the rate of emitting radiation will be more. Now the conclusion of all, we have three factors affect the emitting and absorbing or the rate of infrared radiation, color and texture, dull black better absorbers and emitting of radiation, shiny silver, they are bad in absorbing and emitting radiation. Surface temperature, high temperature faster in emitting radiation, low temperature slower in emitting radiation. Surface area, large surface area, faster in emitting radiation, smaller surface area, small in emitting radiation. Return back to our slides. I return back to our slides where we stopped in one question. See this question number 3. Now, in this question, as you see, bread can be cooked by placing it below here, but not touching a heating element. Here is the heating element, here is the food. Now, which process transfers thermal energy from the heating element to the bread? A, conduction, B, convection, C, insulation, D, radiation. So as you see from the heating element, it will be radiation. So the answer will be D. Second question, the diagrams show 4 cans in a cool room. They are painted as shown here in the figure. One pair is filled with hot water and left to cool down. The other pair is filled with cold water and placed near infrared radiation heaters. This is the figure. Hot water, then after they placed in front of infrared heaters. Now the question, the hot water in the black can cools more quickly than the hot water in the white can. Now the cold water in the black can heats up more quickly than the cold water in the white can. Now, which row shows the reasons for this? Now, A, yes, yes, for A, better emitter of infrared radiation, and second one, better absorber of infrared radiation. Now, A, black, B, A also the second one, black, B, black, white, C, white, black, and D, white, white. So as we discussed before, that the better emitter and absorber is the black one, so the answer will be A. Next question, number 6. The diagram shows 4 similar cans. Each can contains the same volume of water initially at 80 Celsius. After 5 minutes, which can will contain the coolest water? Which one? So as you see, this is A, dull black. This is B, polished silver. C is covered with lead and it is dull black. D, it is polished silver and it is covered with lead. Which one will be the lowest temperature or the coolest water? So the answer for sure A, since it is the without lead, without cover, and it is dull black. Now, the applications of radiation on our Earth. Now, thermal radiation also and a greenhouse effect. So as you see, here is our Earth and the atmospheric layers around our Earth, and here is the sun. Now, at the beginning, solar radiation passes through the clear atmosphere. Then after, most of the radiation is absorbed by the Earth's surface and warm it up. So without this absorbing of the solar radiation and the heat trapping on the atmosphere, the Earth's surface would be about 25 Celsius cooler than it is. Now the third, some of solar radiation reflected by the Earth and the atmosphere. The infrared radiation is emitted from the Earth's surface, and some of the infrared radiation passes through the atmosphere, and some is absorbed and re-emitted in all directions by greenhouse gases molecules. The effect of this is to warm the Earth's surface and to lower the lower atmosphere. So this is the application in agriculture. In a greenhouse, the sun's thermal energy passes through the glass panels, warms the ground inside and heats the air, but the hot air then becomes trapped inside to help in agriculture. Third application, solar panels use the sun's thermal radiation to warm up water for the house. A blackened layer behind the pipes absorbs the radiation energy, heating the water in the pipes. The last application, I will talk about this application, which is vacuum flask in details in the second slide. So vacuum flask, as you see here, a vacuum flask can keep drinks hot or cold for hours. It has this feature. So the features for reducing the rate of the thermal energy flows out or in. Now, an insulated stopper, this one, insulated stopper, to reduce conduction and convection. Now, a double-walled container, which is this one, the second one, a double-walled container with a gap between the walls. Air has been removed from the gap to reduce conduction and convection. Walls are silvery surface to reduce thermal radiation. So these are the applications all of them. See now this question. A student needs a double-walled glass vessel to contain a hot liquid. So as you see, here is the hot liquid. Here is the glass Q space, and the glass second one R, and S, then air outside. The question is, what reduces heat loss by radiation? So a vacuum in the space between the walls. Now painting surface Q black, painting surface R black, painting surface S silver. So which one will reduce the radiation? Send me your answer. The summary of radiation. Radiation is the process by which heat is transferred from one body to another along straight lines. Yes, and here we have two examples, microwave and the radiation from the sun to the earth. So as you see, in microwave, the food is getting hot, yes, by the radiation of the microwave, and also as well the heat is passed from sun to earth, most of from through the space and as well through the atmospheric layer. So this is the summary about radiation. And this is the end of our session, the transfer of heat. Thank you.